All right. Good morning, everyone. I hope you all found this place very easily and there was no traffic. At least I didn't find any traffic on the way. So I was able to reach from Airoli. I stay in Airoli. From there to this office in, I think, 35 minutes or so. So after a couple of very good sessions, we'll talk about something related to AI, which is like a hot topic. Everybody is talking about AI and everybody is doing AI. In this session, we will not focus on cost part at all, because when we are talking about OpenAI and stuff around that, usually you should keep cost aside. So we will rely on our friend to take care of that later on when we decide to go to production and stuff like that, right? So today we'll be talking about RAG pattern. How many of you have tried their hands-on OpenAI? Excellent. And how many of you know what is RAG?
Around 70%.
Yeah. How many of you know what is RAG? 3, 4. That's good to know, because then this session will be really useful. Okay. So we'll talk about RAG and we'll talk about in OpenAI a little bit. So OpenAI basically is an LLM, because there are around 30 to 25% of people who don't know about OpenAI. I'm sure they would be knowing about OpenAI, but they might not have had their hands-on OpenAI because of the cost and other stuff. I don't know how many times we will talk about the word cost, but I'll try to restrain from it. So when we talk about LLMs are trained on specific knowledge base, right? There is a specific cutoff date to which these LLM models are trained. Although they have world knowledge, they know a lot about the information which is there in the world, but there is a specific cutoff date. So beyond that date, LLMs would not know what has happened, right? So if you ask LLM about what is the election date in Mumbai, it will not know. It will not have any clue, because it is not trained on that, right? But what LLM are good at is they are very good at reasoning and understanding what people are asking, right? And that's the ability which is used in most of the LLM based applications. Whenever you see LLM based applications, they are primarily used for their reasoning abilities and understanding abilities, right? At certain instances, they are also used for the translation and stuff like that. So what do we do in cases where we want to leverage on their reasoning abilities, but the knowledge is not there? So in those cases, there are two options which we have. Either we provide LLM with that knowledge and ask LLM to do something about that knowledge, right? So for example, if I provide if I go to Election Commission of India website, I download the dates of the voting along with the state information, and I provide it to the LLM, and then I ask LLM, when is the voting in Mumbai? It would be able to answer, because now it has the information, right? So that's one way through which you provide data externally to LLM, and that kind of pattern is called as RAG pattern. It's called as retrieval augmentation generation, right? Which means that you retrieve some data from some external source. External source could be anything, and you provide it to the LLM, and then you use the reasoning capability of LLM so that it can tell you based on that data whether the question you have asked, the answer is there inside that data or no. In addition, at times we can also add additional information using the global world knowledge which LLMs already have, right? So it means that you can ask about the election date in Mumbai, and you can also ask something else about election, like when election happened, what was the earlier election date? I don't know which year it happened, 2019 I think. So in 2019, what was the date in which voting happened in Mumbai? So LLM would know that information. So along with the information which you have provided, it will use its own knowledge base, and also then you will get a good comprehensive detail, right? That's one way through which you can get the latest information from the LLMs, large language models. The other way is that you can fine tune LLMs, right? So what fine tuning means is that the way these LLMs were trained earlier, the way the information was provided to those LLMs, using similar techniques, you provide additional information to the LLM so that it has that additional knowledge base also. But the problem with fine tuning is that fine tuning is very, very expensive. It requires large amount of GPUs and all. And with the size of models which we are dealing with nowadays, it's really difficult to run fine tuning on a complete model. There are other models which we call as SLMs, which are small language models. They are good for the fine tuning use cases, where you can fine tune them and get your knowledge base inside them and use the reasoning ability. But they will not be able to do correlation. They will not be able to do correlation very well because they don't have the world knowledge, and that's why they are small in size, right? So these are the two options. Out of these two, RAG is really economical. It is not expensive. It doesn't cost you much to use this pattern and use the latest knowledge base on LLM and use its reasoning abilities. Fine tuning is expensive, right? So that is about the RAG pattern. It is, you would see like almost all the applications or all the companies which are doing OpenAI or LLM based systems, they will always have one or the other functionality which uses RAG, because there are a lot of corporate policies, a lot of internal documents, a lot of things which is not exposed to the public. And we already know in theory all the LLMs are trained on public data, right? So corporate related information is not exposed to public. So the only option which is left over there is either use RAG or shell out a lot of money and do fine tuning. In some cases, RAG still performs better than fine tuning because with the fine tuning, it will still add additional information which you may not want. And this concept is called as grounding the knowledge, right? So you want to restrict the information to a specific domain. You don't want LLM to go beyond those domains. In those cases, RAG is particularly very useful again, right? So these are the usual steps which are required for the RAG based system. So what I said earlier is that you have some data source from where you collate the data, and then you pass that data as a context. Let's call it context from here onwards. You pass the context to LLM, and then you ask questions to LLM that based on this context, provide me this information, right? And because you have grounded LLM on that context, the LLM will not really go beyond the information which you have provided. Of course, your prompt has to be that much intelligent enough to restrict the LLM to go beyond that. But usually that's not a too difficult thing to do, right? So you have data source, you extract information from that data source, provide it to the LLM, and then you ask questions to the LLM. In between, so there is something called as vector store. How many of you know what are vectors? Excellent. So we will not explain that. So there is something.
You have to explain.
Okay. So vector is basically, it's typically used in AI ML domain a lot. So if you have a particular word, say for example person, and you vectorize it, in layman language it is called you can say that you are converting it into numbers. But when you convert into numbers, it's not person which gets converted into numbers, but the other information which is related to person. Like for example, king is usually a person, right? So when you generate the vector of a particular word, it has words along with the relationships based on how much dimension the vector is. The larger the dimension, the larger the relationship is, right? So for example, so if you have a vector generated of person and you ask it how much it is similar to man, typically it will say like 100% or more than 90%, because man is a person, right? And when you do vectorization is not just converting that particular word into number, but associating the relationship also, right? And the OpenAI model which is there for vectorization, it has very high dimensions. I think 1536, something of that sort, right? More the dimension, better is the capture of the relationship, right? So why do we need to convert our data into vector and store it in a vector? Vector database is a database which is highly optimized to search on these vector queries. So it has internal algorithms implemented wherein you need not find out which vector is similar to this vector, to the vector. That database will take care of, and it will store it in an optimized way, right? So whatever text we have, we vectorize it and store it in a vector database. Now, why do we vectorize it? Because we want to support the similarities. So, if I have some corporate HR policy which talks about employees, right, and I vectorize it and store it in a vector database, then the queries may need not be just on the employee, but it could be like, what are the policies for the manager, for example, right? So manager, employee is a manager, manager is also an employee, right? So like that, the relationship will be determined, and a user can freeform do the queries in the native English language. It all, not just English, high dimension vectors usually support a lot of other languages also. So we will see that in a demo short while, right? So we have our data source, we have our data, we vectorize it and store it in a vector database, right? And then whatever we want to search, we put that query, we fire that query on the vector database to get the similar paragraphs from the source which we have already vectorized, right? We'll see in the demo short while. And once we get that paragraph, that is our context, which we pass to the LLM, right? So if you see here in RAG pattern, LLM usually does not play a lot of big role in terms of engineering. Functionality wise, obviously LLM being a reasoning system, it is supposed to be the most critical system in the path, right? But when you talk about engineering, LLM, I mean, you just pass the context, make a call, and LLM will give you the response. Looking at the appropriate data source, pulling out the appropriate records, manipulating it in such a way that it is searchable, right? All those pre-processes, transformations, we call it as a preparation step, right? So those things, those are the things which require a lot of engineering efforts to reach to a state where we are able to get the proper contextual information which we can pass to the LLM. And there are a lot of tools which, okay, I forgot that there is an animation in this slide, sorry. So raw data sources, like for example, there could be files, PDFs, databases, anything, right? And then when we are extracting information, so if it is, for example, 2000 pages document, we can't just vectorize it and store it and expect output to be in a reasonable format, right? Why we can't vectorize and store it 2000 pages? Obviously, we can vectorize it using models, custom models, or OpenAI might not vectorize it, but we can use Hugging Face models and vectorize it. But the output which you will get when you fire a query, it will be entire 2000 page, right? So that's why it is recommended that you chunk the document into smaller logical parts. There are various strategies. Again, whatever small icons which you see here, this is not just the full set. There could be a lot of other sources also, but I thought that 3 is good enough to explain that it can go to n, right? So there are quite a few strategies, like for example, fixed size chunking. So if you have big document, you say that every 100 words you vectorize it you split the document into 100 words, right? So that is fixed size chunking. There is something called a semantic chunking, which actually it divides your document into logical fragments. It keeps those fragments together and then it divides that document accordingly. And then there is a token based chunking. Token based chunking means that you say that my model which is generating embedding supports, say for example, 100 tokens. Then there are libraries which help you to calculate number of tokens in a sentence, and using that library you can decide on the token based chunking, right? Eventual objective is that you have big document, you want to split it up into small paragraphs so that the context when you pass to the LLM should be small enough for it to process, right? And then we generate embeddings. Now embeddings can be generated by OpenAI, or you can use custom models from Hugging Faces. OpenAI is supposed to be the best model to generate embedding because it has the highest dimension so far as I know for the embeddings, right? And then we store it in the vector database. Now there are a lot of vector databases. There are open source vector databases, and there are proprietary databases like the one which we will talk about today. When we talk about open source vector databases, there are databases like Redis. I don't know if Elasticsearch also supports vectorization to some extent. But we are going to focus primarily today on the Azure AI Search, right? Azure AI Search is similar to Elasticsearch in functionality, but a lot of other features which are added. And again, as I said earlier, majority of engineering work will be involved in getting the document into a searchable state. That's why in RAG pattern, the primary focus will be on preparation of your data rather than actual query and stuff like query. And also there would be some engineering involved over there, but that's a that's a well documented steps thing, like how do you do those things. So that is very well documented. Here, there is a lot of complexities involved because, for example, if we are taking PDF, right? PDF can have images, it can have tables, it can have text and things like that, right? So when we are doing chunking, we have to identify images separately, we have to parse the tables and stuff like that, right? So a document can be a structured document or an unstructured document. If you get the structured data, then it is well and fine. Then like your half of the job is done, right? So that's a preparation step in the RAG pattern. And okay, so this we already talked about, right? I think we should not keep animations in the slide. So once we have data stored in our vector database, then we need to figure out how do we get answers for our queries, right? So the steps involved will be typically you create a query. Like for example, the use case which we are going to see, we have a data set of various tourism places in India. It's a data source set which is available on Kaggle freely. Using that data set, we will query to find out which are the best tourist place in Maharashtra. So if this is the query, tourist place in Maharashtra, so we have to convert that query into a vector format, right? So first we decide on what we have to query, we convert it into a vector format, and then using that vector we query, we fire that vector query on the vector database. What vector database will do is, based on the algorithm which we have specified, it will do a similarity search, right? And once the similarity search is done, it will return me the corresponding text with that vector, right? Usually it's a one-way thing, like you cannot convert vector back into the text as far as I know. If somebody has an alternate opinion, feel free to interrupt. You can convert text to vector, but vector to text is not possible. So that's why when we are storing vector, we have to store the corresponding text also, that this is the text and this is the corresponding vector. So that when we do a similarity match, we will match against the vector, but we will process the text, because processing vector will not make a lot of sense, right? So we create the context with the output which we got from the query, and we pass the output to the LLM, and from the LLM we can get a properly formatted answer, right? So these are the two major phases in RAG based application: pre-processing and then using the data which is stored in the vector database to get the required answers, right? So with the any questions on the RAG process as such? Yeah.
Where is that association of keep text and vector is stored?
You can store it in the vector database. Yes. So typically a vector database will not be just for vectors, it will also support text and other columns. At a very, very high level, you can consider that if you are on moon and you are looking at Earth, at that much height, you can consider that it's like a RDBMS database with one column having vectors, right? So Azure AI Search is one of such vector database, which we will talk about in the subsequent slides. And the reason why we are talking about Azure AI Search and not Redis or any other vector database is because this is an Azure conference, right? So Azure AI Search, it's a feature-rich vector database. I think this should not have been first line because we didn't talk about the features at all, but trust me, it's a feature-rich vector database. It allows you to ingest data from various data types and sources. So you can use Azure Search to ingest data from the data sources which are in Azure itself, like for example, Blob Store, RDBMS or any other data source, or you can use it to ingest from outside Azure as well. That is also possible. And there is a feature called as integrated vectorization, which we will talk about a little bit later, which is supported in Azure AI Search. So this kind of makes our task very easy in converting the text into vector and storing it into a database. It has state-of-art semantic ranker, which kind of once you have the records searched, the semantic ranker ranks those records as per the semantic meaning of the query and returns back the results. The normal search will just give you the best possible matches which are there and it will return back the response. But when you do semantic search, it will find out the best possible matches, compare it with which one of them is semantically best match with the query, right? So, right? So, do you all understand what do I mean by semantic ranking?
Similar meaning, association.
Yeah, meaning similar to the query which you have given, like I am thirsty. So it has a specific meaning, right? So in your response, whatever you have written, thirsty word might have been at n number of places, but which one of them makes sense to this particular sentence?
Okay.
That will be ranked higher.
I've read that it is weighted in some ways. When you
Yes.
query whatever the result is weighted highest is the result for. Is that correct?
Right. Yeah. So when we do semantic ranking, the weightage is based on the semantic meaning of the.
I don't want to give you. So in new generation, once you meant thirsty, right?
Thirsty.
There's also thirst trap.
Yeah.
Same word but total different. Thank you.
Yeah. So that record will be dropped. AI search is enterprise ready. As like any Azure service, it allows you to do all the authentication, authorization, and whatever enterprise features which you want for a service to go into a production, right? So all the thing is already there. Data encryption. So AI search encrypts your data at rest. So nobody is able to get that data unless they have the specific keys and all. Network isolation. So you have, like in Azure, you have various kind of network things, right? You can create private networks or you can just keep service exposed to the public. So all that feature is also there. It has very good integration with all the popular libraries like semantic kernel, LangChain, Llama Index, etc. So if you go to any of these libraries, for example, if you go to LangChain, there are libraries for vector store. So AI search is also a first class library over there. It provides a very good integration. So coding wise, it's very easy, right? So those are some of the features of AI search which makes it very convenient and easy tool for storing the vectors and retrieving the vector information from there, right? There are the various type of search which Azure AI search is like supports is one of the search is vector search. So vector search, there are basically couple of algorithms which are used for vector search: exhaustive KNN and hierarchical and ANN. ANN is approximate artificial neural network. No. Approximate nearest neighbors, and KNN is K nearest neighbors, right? The difference between two algorithm is that, as far as I can recollect, KNN will see each and every record, and then it will figure out which one is the closest. Whereas approximate nearest neighbor, inside that the sub algorithm is HNSW, which kind of maintains the hierarchy. So it will not scan the entire data set, but it will scan the approximate the data sets which are closer to each other. The bottom line is that ANN, as far as I know, is faster when we have larger data set, right? And KNN will be faster when there is a small data set because it has to go through everything, right? The beauty of vector search is that you can have multimodal searches as well. So you can have text, you can have images, because end of the day everything is a number. So the comparison will happen from a number to a number. It doesn't matter whether image is converted into a vector or text is converted into a vector, right? So multimodal is there. We can have additional filters as well that will reduce your set of which. So in addition to the query which you have fired, you can also have additional, like for example, if you have a review data, Amazon review data in your vector, you can say that reviews which are best, and you can say rating greater than 4. So in the filter you specify rating greater than 4, so that will reduce the set, and then it will use the reviews which are best for the vector matches, right? Vector search also using the integrated vectorization technique. Integrated vectorization, I think it is in preview mode, public preview right now. It's not GA yet, but using that you can have end-to-end ingestion, chunking, and everything implemented out of the box, right? You don't have to write a single line of. I mean, you have to write some code for that, but most of the heavy lifting will be done by the platform itself. And of course, it will increase the cost because more work is done by platforms, so it will become more expensive, right? So in addition to vector search, Azure AI Search supports semantic searches. Semantic searches we talked about just a bit back, right? So it will search the term in the entire text and then rank it based on the similarity to the query, right? And then there are hybrid searches. So hybrid search, I don't think there are a lot of vector databases which support hybrid search. There are very few vector databases which support this technique. So here you can have the vectorization based search as well as your normal searches, right? And the results of both the searches are collated, and then they are some of the records will be dropped from there, and then there would be less number of results which are very much relevant with what you have searched, right? So this is a very good feature, and it's used in lot of projects. So the steps which are involved in hybrid searches is that it first does the full text search, then does the vector search, and then it uses the RRF ranking algorithm, which kind of, so if for example in the full text search and vector search it was able to get say 100 records, using RRF it will reduce it to say for example 75 records, right? And then using the semantic ranking it will reduce it further, say for example 50 records, and then return back those number of records. And Microsoft team is continuously working on improving these algorithms, because this is the only thing which kind of differentiates this product from others, right? So those are three major searches which are available. You can search by vector, you can search by keyword or semantic, and you can do a hybrid search where you will get the vector search and keyword search both, right? So having talked about theory, I'll just move to a demo where we'll talk in bit about the code. I already have, I'll not run everything here.
Can you just increase the? ये direct 12 बजे news करती है.
Okay.
Thank you.
Is it visible now?
Yes.
Right.
So there is the back. Can you see it? Yes. Yeah. Good. Eye test.
मनी दिख रहा है थर्ड रिकॉर्ड पे क्या है? Okay, so this is the data set. Zooming it will not add any value, but still so here we have city, we have places, we have rating, distance, and some other columns, right? So this is the data set which we have used, and because it's a demo, I have deliberately I have selected a very simple data set. Earlier I tried with PDF, but PDF then I dropped it. I said okay,
इतना भी unstructured data, semi structured नहीं देने का.
Which model would you use for multi-model conversion?
Multi-model conversion as in?
Image and text both. Because I was looking for some models, but I couldn't find any good ones.
For vectorization? For vectorization images, in Azure there are models already available.
In build?
Yes.
So they use their own models?
Yes. But open source I am not
there
sure.
Are some There is one, I think, or two other ways, or OpenAI.
I think somebody will have answer for this.
Jetpack, joint embedding, something.
Or Hugging Face.
Mostly. JEP.
Yeah, I mean, this is another good thing of AI sessions. Like if somebody has questions, somebody or the other will always have an answer. So, going to the code, so this we will not talk about much because there isn't anything interesting here. I'm just using the Python dot environment. How many of you don't like Python? Okay, good. I also don't like Python. So, here we are loading the environment file. I will not show env file here because env file has all the passwords and keys and everything, and this session is getting recorded, so I'll have to change that later on otherwise. So that's why I'll not show, right? And then what I'm doing next is that I am search index client. So what I'm doing is that I am using the libraries to connect to my Azure AI search instance, right? If I show you the Azure AI search instance on so this is the Azure AI search which I have created earlier, right? It has various sections, like it has indexes, indexers. We will talk about what are indexes, data sources, skill set, everything, and few more, right? So you can go here and you can create your indexes, right? So to interact with this AI search, we will use this library search index client. So I have configured the service endpoint. Service endpoint is nothing but the endpoint which will be used to connect to this particular instance, right? This one, this is the service endpoint, and then there would be credentials which I will use to connect to this Azure AI search and perform the operations. Typically, admin credential is used for creating the indexes and stuff like that. Right now, okay, this is the one which we should be doing first. So we have loaded the environment, we have loaded the file which we want to process, and then I have connected using this code. I connect to my AI search client, right? And once I connect to the AI search client, I can set the fields of the index. So in AI search, index is like your database. So it has various columns, right? So here I have specified that it has ID column, it has content vector column. This is the column where my vectors will be stored, and it has the content column. So this is the column where my actual content will be stored, right? And here I specified that my vector dimension is 1536. This has to match with your embeddings which you are generating, right? So if you are using some Hugging Face model, it has of a lower dimension, then the value has to differ over here, right? And then I have a rating column as well. This column is not used in the code anywhere, but I have just kept it to show that you can have multiple columns. So the question which you were asking about the content and the vector, right? So this is the content and here is the vector. And then I am using some LangChain libraries to connect to my OpenAI embedding. I purposely used LangChain here just to show that the integration is already there with LangChain and everything. So it is very easy to use that, right? So here I am using Azure OpenAI embeddings, where I specify my deployment, API version, API key, endpoint, validate base URL is equal to true, right? After, so first step I create the client, then I create the index, right? And then I also need to create a semantic search config. I also need to create the semantic search config, so that when the semantic re-ranking happens, it will happen based on which field. So that is defined in your semantic search config, right? So here I am saying that the re-ranking should be on basis of the content, because right now in my index that's the only field which I have, right? And then I create the I set up my vector search thing. I set up my vectorization technique over here. So here I have specified few algorithms, like the we talked about earlier, right? There is HNSW, which is ANN, approximate nearest neighbor, and then exhaustive KNN algorithm, right? So both the algorithms I am setting up. Not necessary both of them will be used. Which one to use, that I can specify in my later on down the line, right? So here I am using HNSW, I set up algorithms, I set up my vector profiles. These are standard techniques. That's why I'm not That's why I'm not waiting here for longer time. We'll go a little fast because these standard techniques you will find out, you'll be able to get anywhere if you Google, right? The only important things which I think are important that I'll try to explain, right? And then we specify a vectorizer. Okay, so we create a vector search object and then we create the search index, right? So in the index, we have to specify the index name, we specify the fields on which the index is created, we specify the vector search object and the semantic search configurations, where we specified that what is the prioritized column, right? And then we do create or update index API call, and the index is created, right? So this is the index which I had created earlier, vector demo, right? So this is the index. So if you see fields here, these are the fields which I have specified. These types are specific to the Azure AI Search index. So if you have a vector field, then it has to be a single collection type field, right? Whereas other fields can be string or anything else. Okay. So once I have the index created, I am loading the data from my file into the index. Okay. While loading, the only thing which is important here is that rest of the fields are loaded straight away like as is, but the content vector is loaded in the vector format. So I'm using my vectorizer, making call to ADA model, getting the vector back and storing it in the content vector field, right? And then I call execute batch. Execute batch will basically, it will run the batch and it will load the data into my vector database. Where is the load code? Index. So this API will load the data into my vector database, and I am doing in a batch mode, right? So here I am loading in the batch of 2. So if you see here, there are 2 records which are processed. Every time after 2 records are added to the batch, they are added to the index, right? And if I show you in the search explorer, so this is how it will look like. Okay, so ID, content, forget about the rating as of now. Some of the columns have rating, some of the columns don't have rating, right? And if I want to see the vector also, so right now what I have, if you see here, there are only 3 fields which are displayed. The reason why 3 fields are displayed, because content vector is not retrievable, because it doesn't make any sense to make it searchable and all, right? If I make it retrievable and save it, and then I go again and search here, this is my vector. Okay, this is a very large vector, right? And then I do a vector search. The steps to do vector search is that you should have a query. So for example, here is the query which I want, cold places in Maharashtra. So if I search cold places in Maharashtra, I have to vectorize that query first, right? So I vectorize it using the API. We will not go into details of what is this exactly API. And then we specify the fields which we want to return back. The response is this. So Khandala is considered to be a cold place, right? And it is in Maharashtra, right? So if I say, for example, put hot place in Maharashtra. Oh, I have to run everything. The loading thing I will not run because data is already there. So apparently it has identified Mahabaleshwar as a hot place, although it is not so hot, but because of the right. So what I want to show here is that it's not exactly matching your text, but it's doing the more appropriately, we can call it as a semantic, but it's not semantic actually, because semantic search is a different thing, right? So related, it is trying to go by that relationship, doing a cosine similarity on top of that, and then pulling out the record. And here, if you see, I'm not displaying vector because it makes no sense to display that, right? And when we do semantic search, cold places in Maharashtra, then it will pull out all the records which have Maharashtra written inside it, and it will try to match it will try to re-rank it based on the semantic match of the query which you have fired, right? We will not dissect into what the output is and how does it match to semantic, but you can trust me what I am saying is right. And another good example of vector search is that although I put it in a different language, still it is able to correctly pull out the records like Pune, Mumbai, and all that. And if I show the data set, it has other records also. So it's not that I have put only the Maharashtra records. Right. So this is the beauty of vector search. You can do similarity search as well as you can do it in a multilingual thing also, right? Based on the training of the model, based on what model you selected. So that was about the vector, that was about the storage part into the Azure AI Search. And next what we do is that we have to pull out those records and give it to the LLM so that LLM can give us a proper response. So what we do here is we create the Azure Chat OpenAI client instead of normal OpenAI client, because I have OpenAI installation in my Azure subscription, right? So I am using that. So this is LangChain code. I think whoever has worked on LangChain would know. But what we do here is that we create an LLM object. We create a vector store object, which is nothing but Azure Search. Again, this is also from LangChain. And then we create a retriever, right? And then to the chain, we give the retriever object, and then we fire the query, right? So this is typical LangChain code. Hub.pull, this kind of pulls a prompt which is available on LangChain Hub. All that prompt does is that it writes that you have this particular information available. Answer the question based on the information which is provided below, and then there would be question, and then it will give the answer, right? I'll provide the URL for this code base so you can refer it later on. And then I do chill.invoke. So I say cold places in Maharashtra for trip, suggest places closer to the city center. So what it did is that it went to the AI search, it pulled out the relevant record, went to the LLM and said to LLM that this is the query. Now you use your reasoning ability and give the appropriate response. And this is the response, like you can consider. So the text is like beautifully written. You can consider visiting blah 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 blah, right? And then few options. Okay, so this is about the AI search. This is how do we use AI search for the RAG pattern. Coming back to the presentation, but one might say that Azure AI Search is a platform as a service, right? So and it is a vector store. So why can't it automatically do the vectorization? Because we are using OpenAI and we are using stuff which is provided by Azure, right? So to do that, there is a concept called as indexers, right? So indexers are like batch processes which can run up on a specific schedule, and they would go and they would pull out the data from your data source and do some operations on that. So basically, it's like a pipeline kind of thing, right? Which will pull out the data from the data source and maybe store it into the index, right? And then indexers can be given skills. Okay, so you can give indexer a language detection skill, right? So if you give it a language detection skill and you say that whatever language is detected, give me in this particular column in my AI search, right? So it will go to the data source, it will look at a text, it will identify the language using Azure language detection models, and it will identify the language and it will populate it wherever you want to do. Likewise, there are skills called as PII detection skills, image analysis skills, OpenAI embedding skills, split skill, and a lot more. There are quite a lot of skills. You can write your own skill also, wherein you can expose a web API call, and whenever data load is happening, that web API call will happen, and inside that web API call, you can do whatever you want to do, right? And indexers can also have source to target field mapping also, like pick from this source, put it in this target and stuff like that, right? So with the indexers, they were able to introduce another concept called as integrated vectorization, right? So I have an indexer, I can give indexer a skills of vectorization, and indexer can vectorize the data. Why I should be writing all the code to do that vectorization, right? So here is a pipeline, simple pipeline, in which we are leveraging on the integrated vectorization. So we have the source could be like here I have shown only 2, but there could be more. And then we are using some skills, like for example, split skill we are using to chunk it into fragments. And then we are using embedded skill, which can interact with the Azure OpenAI and can do the embedding. Again, not just, it is not necessary that we should be using Azure OpenAI only, because most of the Hugging Faces modules are also available in the Azure module repository. So you can connect there and do the embedding as well. And then output mapping, where we will define that store this vector in this particular column, right? So that is the integrated vectorization. Now, if you look at the code, when I do the integrated vectorization, we did so many things here. I don't know how much you were able to follow, but I felt that I did a lot of things over here. Okay, but with integrated vectorization, you just have to set up stuff, right? You don't have to write a lot of code. So here, like for example, I have created the index client. I have defined the field. So this is to create the index. First, I have to create the index, right? So same as what we did earlier, semantic search configuration, and then I create a vector search, and then I create an index, right? So this has created my index. After I create the index, I have to create skills. Okay, so I intend to create an indexer which will have some skills. So here, rest of the skills I have commented out, but right now I am giving it only embedding skill. So the indexer which I will be creating will have ability to do embedding, right? And then I create a skill set. Skill set is nothing but you collate all the skills and you create a skill set object in your Azure setup, right? After creating the skill set, now again we have created the skills, but given we have defined the indexer, we have to define the data source as well as the schedule at what interval it has to run, right? So I am defining the data source as a Azure storage account, okay, where I can push the file and the indexer will kick off automatically, right? So I create the data source, and then this is the whole plumbing this whole thing together. So create indexer with skill set. So here I create the indexer, I specify the field mappings. I have already created the skill set, so I specify the what skill set to be used. I specify the data source name and stuff like that, right? Once this setup is done, then I am sorted. I don't need to do anything about the data load. As soon as I push my file into the into my storage account, based on the indexer schedule, it is not as soon as, but based on the schedule, the indexer will run, it will pull out the data and it will push to the Azure AI search. So if I show you some of the previous runs, so here is the indexer, right? And these many times it has ran, right? If I go to this was the success. If there are any errors and all, it will show you the error here, which you can debug. You can open a debug session and you will be able to see all the records and everything, right? But I can run this indexer again. I can reset and I can run it again, and it will do the entire thing again. It will call my OpenAI, it will do the embedding and stuff like that, right? And then the data source which I had created, so this is created here. The skill set which I have created, so this one, it has one skill, it can have n number of skills, right? So these things I have done programmatically, but these things can also be done from the portal very easily, right? So yeah, I think that kind of covers what I wanted to show you. Again, this indexer integrated vectorization is still in public preview, it is not in GA. And one more beautiful thing which you will notice here is that when I was doing the search in my normal way, I was passing the vector in the query, right? But here I am not passing any vector, because the integrated vectorization automatically generates vector from the search string. So in reality, you don't have to really bother about vectors at all, right? Everything will happen behind the scene automatically. And then here is the result. Okay. So that is it I don't know if I have a thank you slide. No. Any questions?
Any question, Pankaj? Yeah. Amal, right?
Yeah, that's right. So I'm very new to this AI world. So basic questions. One is that you mentioned SLM, small language model, and LLM, and you mentioned about cost also. Could you just throw some light on the kind of cost you're talking about and the kind of data sets so that we'll get some perspective?
Yeah, so over here is that you want to understand on the cost perspective from while calling SLMs and LLMs, right? And how does it make difference? So I will not give that question to you. I will answer it. So when we talk about these managed environments, right? The cost is per API call. Okay, and you will, if you look at the LLM based applications, you will keep on talking. If you have used ChatGPT anytime, you will keep on talking constantly, right? Unless you get your appropriate response. And each API call will incur cost because the calls are based, the cost is based on the API call. So it might become very expensive if you have large number of users and they are all using LLMs to do stuff to continuously be in a chatty manner. Your cost will exponentially rise, right? So there are two. The other alternative for that is that you deploy LLM in your own environment, but in that case also cloud provider will charge back something. It will not be that much high, but there will be some charge. So that's where the cost factor is involved. Now, when we talk about SLMs, SLMs are smaller models. They are their cost will be less because the amount of knowledge which they have is less than what LLMs have, right? And in case of applications where you want to just have chat on your local corporate policies, corporate documents and all, SLMs make more sense because you really don't need the world knowledge in that case, right? So go with a cheaper option, go with SLMs. So that's where it.
Yeah, but can you quantify? Can you just do some figures to talk about $1,000 versus $10,000 based on your experience?
LLMs will be substantially way less than LLMs in terms of cost. It will be very less.
Because when that ChatGPT kind of was available
Amal,
publicly,
we'll have to stop that. We want to continue.
Yeah, I mean, we can continue the conversation offline.
You have a question, Janet? Yeah.